Mwesugwa, we are waiting for you.
Yes, sir.
Yes, lead us in prayers, please, and then we start. Mwesugwa. Okay. Cynthia, can you lead us in prayers? Seems Mwesugwa is just going to have breakfast. Cynthia?
The name of the Father, and of the Son, and of the Holy Spirit.
Amen.
Amen. O Lord Jesus Christ, we thank you for this day. Thank you for the gift of life. We thank you for the gift of our parents, teachers, and everybody. O Lord Jesus Christ, as the teacher is going to teach us, may you please help us so that we can understand whatever is going to teach us. And also may you please guide him in whatever thing he's going to teach us. In Jesus' name I pray. Amen.
Amen. In the name of the Father, the Son, and the Holy Spirit.
The Holy Spirit. Amen.
Amen. Thank you very much, Cynthia. Hope everyone had a very nice night, and I hope the morning is also okay. So previously in 3 dimensions, we have looked at very many things in 3 dimensions. First of all, when we started 3 dimensions, I think 2 weeks back, we say that in 3 dimensions, we are looking at shapes that have their sides, they are in 3 directions, in the X, in the Y, and also in the Z direction. And the first thing that we looked at how to determine the angle of projection, on a given figure. In the diagram which is here that we're seeing right now here, we have got something like a book that is opened in that kind of shape, and there are 2 planes. So remember, we looked at the angle of projection. So you can see that if we are to draw the angle projection of M and N, then this angle projection is NP, which is down there. It is down there. So if there is source of light above this side here, where I'm putting the cursor, if there is light or a torch that is directed here, so we shall see the image of that line on this lower plane along NP. So that was the line of projection. And also we looked at how to determine the length of a line. So using maybe trigonometry, using the cosine, the tangent, and also the sine, and also how to determine the length of a line, also using Pythagoras Theorem. So Pythagoras Theorem needs us to form a right-angled triangle, and then we have the length of a line that is needed for us to find it. We did not stop there. We also looked at, I may show you previously what I'm talking about, what we looked at. We looked at also finding the angle between a line and a plane, the angle between a line and a plane. I think that was our previous section, the angle between a line and a plane. So there may be lines and they're telling you find the angle between, let's say, the line MV and the plane ABCD. I want you to remember very well that a plane, what is a plane? A plane is enclosed by more than 2 points. So when you look at the plane A, B, and CD, that is a plane because it is enclosed by more than 2 points, and a line is just enclosed between 2 points. So it's just a length between 2 points, M and V, that is a line, or A and V, that is a line. So if we're told to find the angle between a plane, if we're told to find the angle between a plane, the angle between a plane and the line, so it means that the one thing that you have to do, you have to draw a line on the plane there's a line that you have to do. So if we are to find the angle between MV and ABCD, then we have to draw a line MO on the plane, and that line MO meets with a line MV, such that they have a common point M. And at M, we looked at that. That's where the angle will be situated. Okay, so that's the previous exercise that we looked at, and to find what we were supposed to do there, we had an exercise that we did. I saw people did this question, Maya did this question, and also the rest of you did this question. There was also this question which is here. We did it the last time, and some of you had problems with BD and BD and CD. So I tried out to find for you that to make the corrections for BD and CD. Someone was saying that you get a math error when you reach at this point, but that's not the truth. So I did this part here, and I tried to post it to some of your friends. So if you may see here, posted it to someone here. Let me check. Okay, so I may try to zoom in there and you see. So here they were telling you to find the angle between BD and BG. BD and BG. So I worked it out, and we found that the answer was 90 degrees. That was the answer, was 90 degrees. So the angle between BD and BG, you had to find what is BD, what is GD, or what is DG, and what is also BD, and use the cosine rule. So this is the cosine rule. I don't know whether you can see it there, but you can zoom in, and that is the cosine rule which is there. So you had to find BD, you had to find BD. BD, to find BD, you had to use the triangle BC and D to find BD, and also you had to find GD. So the angle that they were saying was the angle between BD and GD. So inside there, I cannot zoom in here very well, but inside there, that's where you're supposed to find that angle. So you had to get BD using that triangle BCD, and also you had to find BD. To find BD, you had to use that triangle that is inside with that diagonal BC. So BC, it was 13 centimeters, and you had to find BD. Remember that CD was 9, and that was BD. So once you have those sides, you have GD, you have BG. BG was known as 5 centimeters, and BD, you have found it is 15 centimeters. Then you use the cosine rule, and our cosine rule gave us 90 degrees. If you need these answers, it's a matter of going to this, and then, excuse me a moment. I know why people are calling me. They don't know that I'm in a lesson. So let me do this. That's the best thing for me to. Okay, so if you want to know, you just you look for my contact, and I'll give you my contact, then I'll show you everything. Okay, Mwesigwa Romeo, you need also to, you're not getting me very well. Okay, so Mwesigwa, aren't you getting me very well?
Sir, I can't hear you very well.
You can't hear me very well?
Yes.
Okay. Do you hear me clearly now?
I can hear you, but the volume is still low, but I think the problem is with my PC. I'll try to fix it.
Alexandra, can you hear me?
Yeah, I can now hear you.
You can now hear me. Okay. Okay, and then the other answer, the other question that we had was this question here. Remember previously, this was the question here. They were telling you to find DE and DC, DE and DC, DA and DC. So I did that also, and we found out that the angle between DE and EC, the angle between was 58.4. Alexandria sent for you this. Did you look at it?
Yeah, I sent on WhatsApp.
Yes.
No, I had issues with the phone. I'm not on for some time.
So you and the phone, have you solved your problems now?
Not yet.
Not yet. Okay, you need to solve your problems very fast because that's the best mode of communication that we have. Okay, so I sent this, Patricia, you are using my MTN number, but it's better use the Airtel number. That's when you can get in contact. So this was DE and EC. So you can see DE is this corner here, and C is here and E is there. So the angle between DE and EC was done, which is there, theta, which was there. So we had to find what is BC, what is CE, and what is DE. Once you do that, once you get to those sides using Pythagoras Theorem and also using trigonometric ratios, then you can get the answer theta after using the cosine rule. Okay. So today let us look at the angle between two planes, or the angle between a plane and a plane. The angle between a plane and a plane. So I have this figure here. They are saying that the angle between two intersecting planes is the angle between two lines. Let me repeat that for you. The angle between two intersecting planes is the angle between two lines. So what are the intersecting planes? We have the downer plane, CEFB, that is the downer plane, and we have the upper plane, BCDA. So these planes are intersecting. The angle between those two planes is the angle between the lines NP and NM. So the angle between those two lines is the angle between the planes. How do you get these lines? You have to draw them such that they are in the middle of those planes. They are in the middle of those planes. They bisect those planes into two. So line NP bisects the downward plane into two, and line NM bisects this upper plane into two. So the angle between there is the angle that will be between the planes. So they are saying that one in each plane, okay, the angle between two intersecting planes is the angle between two lines, one in each plane, such that the two lines meet at a point on the common line. So these two lines, NP and NM, are meeting at a common point N, and this point N is at line BC, So they are meeting at a common point. They meet at a point on a common line to the plane. So the common line to the planes is BC. You can see that BC is part of this upper plane, and also BC is part of this lower plane. So if I may draw for you the lower plane, I may put here C and here B. See there? See there, and then C there and B here, and then E is here. Then I put F here. Okay, so you can see BC is a line on that lower plane. But again, BC will be also a line on the upper plane. So if I draw the upper plane, something like this. There. So that is the upper plane. Now A, and that is B. So you can see also the upper plane is BCDA. So BC is a common line for the lower plane and the upper plane. Now you draw a line that bisects the lower plane into two. This is the line I'm drawing. Make it dotted. And that line bisects it into two. And this is P, this is M, N, such that this is 90 degrees, that is also 90 degrees there. And now you draw another line from point N bisecting the upper plane into two. There. So this is M. So it means that now these two lines, MN and NP, meet at a common point N. And now this point here, this point N, this is where our angle will be theta. And angle theta now is the angle between the upper plane and the lower plane. And always that point N is at the common line of the planes. The common lines of the planes is BC. It's BC. So they're saying the line of intersection of the planes is BC, line MN and NP are perpendicular to BC. So this line MN is perpendicular to BC, and also line NP is perpendicular to BC at that point N. So the angle between the two planes is the angle MNP, which is this angle here. Is it clear, members?
Yes, teacher.
Okay, good. So let us proceed, and now we look at this example 10.7. Example 10.7, they are saying that the figure below is a cuboid. And they're saying find the angle between the planes BCFG. I have to look at those planes very well. So they're saying BCF and G. So it means that is the lower plane, and ACFH. So this is ACFH. They have done their best, and they have tried to shade that plane that they are talking about, ACFH. So it is that plane that is inside that cuboid. So they're asking what is the angle between the lower plane and that shaded plane there. So we have to draw a line there in the middle and another line there in the middle, and find the angle in between those two lines. So let us draw that diagram and see how we can do that. So I'll come back to my working area here, and I will draw a cuboid. So let me draw a big one so that everyone can see. To measure very well, so I've used 3.5. I want to use 6 here, 6.5. So I'm going to use 6.5. I'm just doing it so that my diagram is very accurate. Okay, now I'm going to draw second one there. That is was 3.5. So somewhere here, do that. I'll call that 3.5. 6.5 somewhere there. 6.5 somewhere there. Another 6.5 somewhere there. Then I'll connect this very fast. We have that. So now I can do this, and do that, and that. Okay, so the next thing that I'm left with is to label. Okay, so we have A, B, we have C, we have F, E, D, and lastly H. No, that's not the last one is G. Okay, now the next thing that I'm going to do is I'm going to do that plane they are talking about, ACFH inside. So let me try to use dotted lines. So exactly. Okay, and H. All right, so what we are supposed to do, if we want to find the angle between this lower plane, BCFG, this lower plane here, and also the plane, this plane here, that is in the middle there. So what we are supposed to do is, let me first ask you, what is the common line of those two planes? What's the common line of those two planes? What's the answer? What's the common line of those two planes? Put up your hand if you know. What's the common line of those two planes? B, C, F, G, and A, C, F, H. What's the common line there? Where do they meet? On which line do they meet? That's the question. On which line do they meet? Those two planes. Yes.
CF.
CF. CF.
CF.
CF. So CF is the line in common for the two planes, A, C, F, H, and B, D, F, C. So what we are going to do is, since we have now located the line in common, this is the common line now. What we are going to do is call it a common line. So what we are going to do is, we are going to now to find the point where our angle is going to be at this line. So the angle has to be at the midpoint of that line here. At the midpoint, that's where the angle is going to be. So we use that point, and now we draw two lines bisecting the lower plane. So I'm drawing the line bisecting the lower plane. And what's the distance of that line? If this is 7 centimeters, what is the distance of this line here? I can call this one N, and I can call this one P. What is the distance of PN?
7 centimeters.
Correct. So PN is 7 centimeters. 7 centimeters. That's correct. PN is 7 centimeters. Okay, and I draw another one from N to meet this other line. But this line I'm drawing is bisecting that plane, that upper plane. So I can call this one, let's say, I can call this one M and call this one M. Okay, it is M. I'm zooming there for you to see it clearly very well. So what is MN? How are we going to find MN? Okay. Patricia, what I'm saying is that we draw a line on the lower plane, B, C, F, H, because they are telling me to find the angle between B, C, F, H, and the plane A, C, F, H. So the angle between these two planes, these ones which I've shaded, the angle between those two planes, the angle between those two planes is the angle between the two lines that bisect them equally. So this line MN bisects the upper plane, this upper plane which I've shaded, A, C, F, H, which they were talking about in the question. And also the line NP bisects the plane B, C, F, G. So now, where these two lines meet, N and NM, or NM and PN, where they meet, that's where our angle will be. So the angle between those two lines that I've drawn that bisect those two planes will be the angle between the two planes. The angle between these two lines, MN and NP, is the angle between the two planes. Why? Because this line MN is on the upper plane and this line PN is on the lower plane. It is on the lower plane. So the angle in between those two lines is the angle between the planes. So our angle is theta. So now I was asking you, Patricia, is it okay? Patricia, is it okay now? Okay. So now what we are going to do is we are going to find, thank you. So we are going to find the line MN. The line M what? MN. Now, when you look at line MN here, the length of MN, it is the same length of AC, isn't it? It is also the same length of HF. They are all equal. Why? Because you can see that they are all diagonals cutting from one point to this other point. So, and they lie on that kind of plane that is inside here. The plane A, H, F, and C. They lie on that same plane. So, how do we find NM? So, to find NM, we shall find AC. Remember that this distance is 5 centimeters. So we have to find AC. Once we find AC, then AC will be equal to MN will be equal to MN. So let us proceed and we draw a right angled triangle ABCD and we find AC, and AC will be equal to M and N. Okay. So I'm drawing the right angled triangle. I'm drawing ABC. So this is A, this is B, and this is C. So this is 5 centimeters, 7 centimeters, and this is 90 degrees. So my task is to find the SC. Once I find the SC, my SC will be equal to MN. So we shall use Pythagoras Theorem and we shall say SC squared equals to AB squared plus BC squared. So SC squared equals to 5 squared plus 7 squared. SC squared equals to 25 plus 49. So SC squared equals to, when you add there, what do you get?
74.
You get 70 what?
74.
74. So to get SC, we find the square root on both sides. And SC is equal to, that time, SC is equal to square root of 8 point what?
8.60.
8.60 centimeters. So now, since we know our SC is 8.60 centimeters, so the next thing that we are going to do is we are going now to say that MN equals to SC. So from there, after finding our SC, which is 8.60, so we can come and say that MN equals to SC, but our SC is 8.60 centimeters. So that means that our MN equals to 8.60 centimeters. Okay, so we have obtained MN. So our MN, we have seen MN equals to 8.60 centimeters. That's what we have got. So now we are going to draw a triangle that is inside here. There's a triangle PNM inside there. We're going to draw it and find the angle that is in between. So if I proceed there and I draw the triangle, maybe let me use this so that we have the correct flow of our working very well. So I'm going to draw the right angled triangle. Which right angled triangle am I drawing? As you may see in the diagram there, the right angled triangle I'm drawing is this triangle here, MNP. So here I can put dotted lines and show you that we have a right angled triangle inside here, and that is 90. That is 90 degrees. Okay. So it means that here I have M, P, and I have this side N. Have that side N, as you may see the diagram, the way it is there. So PN, we already saw that PN is 7 centimeters. So I'm going to put 7 centimeters. So I'll put 7 centimeters. And then when we look at what is our PM. So PM, what is the distance of PM? Members, are you there? What's the distance of PM?
5 centimeters.
Yeah, 5 centimeters. So I've written 5 centimeters. So this is the angle they want. The angle they want is the angle that is in between P, N, and also M, N. That's the angle they want. Why this angle? Because this angle is between these two lines, MN, and MN is on the plane A, C, F, and H, whereas PN is on the plane B, C, F, and H. So the angle between those two lines, and these lines are bisecting those planes. MN bisects the upper plane into 2, and PN bisects the lower plane into 2. So the angle between those two lines is the angle between the planes. So for us to determine that angle theta, then we are going to use now the Pythagoras theorem and we find theta. So this is MN and this is PN, angle theta. So we shall say tan theta equals to the opposite out of the adjacent. So tan theta equals to 5 divided by, say, 7. So theta equals to the, okay, I think there was no need even of finding SC because AB was given. So theta equals to tan inverse. Have you discovered that, members? Have you discovered that there was no need of finding this SC because AB, we knew it was 5. So theta equals to the tan inverse of 5 out of 7. So we shall,
35.5.
it is what? 35. 35.5. 35.5 degrees. Okay. 35.54. So they rounded off to 2 decimal places. You can say 35.5. That is also correct answer. Let us have one more example and then we shall see. Now I'm not going to do a cuboid, but I'm going to do a pyramid so that you understand about a cuboid and also a pyramid. Is it okay, members?
Yes, teacher.
Yeah. So let us look at this pyramid here. So they're saying that the figure below is a right pyramid on a square base. The slanting edges are 8 centimeters. Kabame, are we together?
Yes.
Okay, Letitia. Okay, they are telling you that these slanting edges, these ones are 8 centimeters each. They're asking you find the height of the pyramid and also find the angle between the slanting edges. Find the angle between the slanting edges make with the base. So they're asking what is the angle between the slanting edges and the base. I think that's, yeah, they are just looking at the angle between the line and the base in part B. And part A, they are telling you to find the height of that. I think that is quite another question. I want something where they have the angle between two planes. Okay, we can go for number 4. Number 4 is quite interesting. Number 4. So members, copy that question. Copy that question. Copy that question number 4. Copy that question number 4. We have just less than 1 minute. I don't know whether you can have time and copy, but in the next time, we shall start with that question number 4. We shall start with that question number 4, and we shall first find the height of the pyramid and also the angle between the planes VBC and ABCD. If we have more time, we shall look at more questions so that we understand this, and you have a test on Friday about 3 dimensions. So you have to prepare and you have to use this time to ask questions for you to understand. Okay.